All right, welcome to podcast 7.3b. This is a continuation of percent composition in 7.3a. Now, percent composition is a really useful tool for analyzing the makeup of a compound, whether it be something that's been invented or an unknown chemical scientists have found in the wild, in nature, that kind of thing. So when you have a percent composition, you want to find the formula of something. And where that kind of all starts is with this thing called empirical formula. And you can see right here with the definition is it's just the simplest ratio of elements. And since we've been talking about moles, if we think about the molar ratio, sometimes that might help. Now, if you look at these three compounds, formaldehyde, acetic acid, and glucose, they're all made up of carbon, hydrogen, and oxygen. And if you look at the ratio of atoms, they can all be reduced down to this. Kind of like if you reduce down a fraction. If I reduce 4/8 down to its simplest terms, that equals 1/2. Well, when I look at these, if I divide all these subscripts by 2, I get CH2O. If I divide all these subscripts by 6, I get CH2O. So all three of these compounds have the same simplest formula. And you'll see in just a little bit why that's so important. So let's just practice real quick. Look at this thing right here. Now you can stop the video at any time, and if you want to try these three, feel free to do so. But we've got this thing C4P2Cl6. How could we reduce that down to its simplest formula? Well, you may notice that they could all be divided by 2. So if we divide these subscripts by 2, we get C2P and Cl3. What would be the answer for this thing right here? Okay. Hopefully you can see they can all be divided by 3. So we get C4H03 and 2. And then look at this last one right here. Right? Now you may notice there's not one number that will divide into all three of those, into 3, 8, and 4. And so that is the empirical formula. And so basically what all this is just how important, let me do this for a second. Now how can this ratio be found? Well, it all has to do with the number of moles, and that's kind of where our percent composition comes in. So let's say, for example, I had this unknown chemical, and the percent composition of this unknown chemical was 60% carbon, 13% hydrogen, 26.6% oxygen. How could we find this empirical formula? Well, it all has to do with what is the ratio of moles of carbon to moles of hydrogen to moles of oxygen. Okay? And to do that, there's just some little bit of math that we have to do, and you'll find that it's actually something very reasonable. So let's look at the next page. And this looks like a lot, but let me just go through it, and you'll find that you can already do a lot of this. Well, the first thing is, as was just stated, this is what our analysis shows right here. And so the first thing we're going to do is we're going to pretend we have a 100-gram sample. So if I have a 100-gram sample and 60% of it's carbon, well then that means 60 grams would be carbon. If 13.4% is hydrogen, then 13.4 grams. So that's the first step. Just change your percent sign right here to grams. Okay? Now the next step is to find moles. And hey, we're good at finding moles. We convert grams to moles, no problem. So as you can see in this step right here, I took 60 grams of carbon, divided by the molar mass of 12.01 grams per mole, and I got 5. Okay? And now what we have is we have the number of moles of each of those. And now it's something we can compare. We can't really compare grams to grams because we're dealing with atoms that are different size and different weights. But now we have them into moles, and that's something we can compare. So what I do is I try and compare all of the moles with each other. And so we do that by dividing by the smallest number of moles. So if you look down here, the smallest number of moles is 1.66 of oxygen. So I divide that by itself, I get 1. 13.3 moles divided by 1.66 equals 8.01 moles. And 5.00 divided by 1.66 gives 3.01. This is now a ratio of moles. Oops, let me try to spell that, a ratio of moles to each other. So how does that work? Well, now that we know that for every 1 mole of oxygen there are 8 moles of hydrogen and 3 moles of carbon, we have now the empirical formula. So this empirical formula, this unknown chemical, is C3H8O. Super powerful technique to find, to analyze a compound. And all you need really is to know what the percent composition is. So let's try a couple. Here we've got 2 right here. Compound of silver has the following composition. Okay, so let's do this. The first thing we're going to do is we're going to change those percent signs to grams. So I'm going to go ahead and write for silver. I'm going to write 63.5% or grams, sorry. All right. For nitrogen, I'm going to write 8.25 grams. And for oxygen, I'm going to write 28.25 grams. Okay, now I have grams. What do I do next? Well, I find moles, and we can do that. We're very good at finding moles. So 1 mole of silver weighs 107.87 grams, right? Let me erase that. Okay. And that equals 0.589 moles. Okay. Nitrogen, 1 mole of nitrogen weighs 14.01 grams. That also equals 0.589 moles. Oxygen, 1 mole of oxygen weighs 16.01 grams. Oops, I don't know where I got the 01. How about just 16.00? Okay, and that equals 1.77 moles. Okay, so now we have them in moles, and we've got to compare the number of moles of each to each other. So to do that, we simply divide by the smallest, and you can see for silver and nitrogen, they're both the same, so I'm going to divide them all by the same number. That equals 1. Divide this one by the same number, 589 moles. That also equals 1. And this, 589 moles, equals 3. So if we look at those 3 to 1 to 1, we get a formula of AgNO3. And what do you know? That's silver nitrate, right? So what's a way to remember this? I'm sitting in class, it's a test, quiz, whatever, and I'm trying to remember how to do this. Well, this is a little something I picked up from a teacher, and it's just like a little phrase. It'll help you remember it. Percent to mass, mass to moles, divide by small, times to whole. Say it a few times. Or if you want to, as I said here, go ahead and sing it. All right? The part that you don't know yet is the times till whole. But all the other stuff you do know. So let's go ahead and try another one so you can see what the times till whole means. So I'm going to do this second question here. All right, we've got a compound. Now this compound has 4 elements. I'm going to move this up a little bit so I can have some more room. So here we go. So for potassium, I've got 38.4 grams. Now notice they gave us grams here. Does that bother us at all? No, we just don't do the first step. The first step is percent to grams, and they already gave us grams. So we've got 34.8 grams of potassium. And I'm just going to write 1 mole is 39.098 grams. Okay, and that equals 0.982 moles. Right? My next one is carbon, and we've got 23.7 grams of carbon. 1 mole of carbon is 12.01 grams. That gives me 1.975 moles. The next one after that is oxygen, 36.6 grams. 1 mole of oxygen is 16.0 grams. That gives me 2, oops, 3.32. There. Oops, we're having some. Sorry about this. We're having some technical difficulties here, guys. All right, let's try again. Maybe I'm writing too fast. 2.29 moles. And then last but not least, we have our hydrogen that is 1.66 grams. So 1 mole. Hydrogen was 1.08 grams. And you get 1.64. Right? So we've got our second step, grams to moles. What's the next in our little phrase? Divide by small. So if you look here, you can see that potassium is the smallest one at 0.982. That equals 1. 0.982. That equals 2. 0.982. That equals 2.33. And last but not least, 0.982, and that equals 1.67. Okay? Now here's a problem. We cannot have a formula that's got H 1.67. It doesn't work like that. Atoms combine in simple whole number ratios according to Dalton. So we've got to come up with a number that we can times all of these by, right here, this whole thing, in order to get rid of this 0.33 and 0.67. And hopefully you know that 0.33 is a third and 0.67 is 2/3. So if I times all of this by 3, this is my empirical formula. K3 C6 O. Now 2.33 times 3 gives us 7, and 1.67 times 3 gives us 5. So there's your times till whole part. Hopefully this is making sense.